Thank you very much. Good afternoon, boys and girls, and I would like to welcome you to this online learning platform. My name is Teacher Bothwell, and I hope I'm going to be finding you well, in good health, and in good spirit wherever you are right now. It is a very good thing for you to always be able to watch the videos because they give you a better understanding on what really transpires in mathematics. So I'll just quickly go to yesterday's work. Actually, it's not yesterday, it's the day before yesterday when we had mathematics. So that day we looked at different issues. I would like to quickly move on to what we looked at. Right. We went on to discuss on this. This is what we did, and this is the work that some of you were supposed to have done. So the first one was saying, write down the name of each spatial quadrilateral that is described. All of my sides are of the same length. My diagonals bisect each other at 90 degrees. And I have order 2 rotational symmetry. If we look at these shapes, of course, this square has already been eliminated here because it doesn't have an order 2 rotational symmetry. And for the shapes that we say they've got an order 2 rotational symmetry, we look at the square doesn't have. Let's go to the rhombus and check whether it fits in this description. All of my sides are of the same length. 2 pairs of parallel lines, my diagonals bisect each other at 90 degrees, right? Diagonals that bisect opposite angles are equal, diagonals that bisect each other at 90 degrees, and it's very correct. So you can see that in this case, a rhombus is fitting this description because all the other shapes don't have all sides equal. So this one is a rhombus. I've ordered 2 rotational symmetry. We talked about rotational symmetry of a rhombus, and we said it has got only 2. The next one is my diagonals cross at 90 degrees, but I have no parallel lines. Let's look at a kite. Doesn't have any parallel lines. If we look at the characteristics of a kite, it doesn't have any parallel lines. A square has got parallel lines. The sides are parallel to each other. If you look at even a rhombus does the same. The other ones, a rectangle and a parallelogram, do not have diagonals that bisect at 90 degrees or that meet and make a 90 degrees angle. So a kite will only be the shape that is there. So the first one, if you have got your work, if you have got your book with you, I would rather ask you to do this work together with me because I'm just revising the work that you were supposed to have done last time, right? So the first one we said it is, let me just try to draw here. Okay. The first one here, we said it is a rhombus. Then this one, let me reduce the font size of this. It's a rhombus. Then the second one, my diagonals cross at 90 degrees. It is a kite. The third one, I have 4 corners. All of them are 90 degrees. Of course, this one has already eliminated the likes of a kite, a trapezium, an isosceles trapezium, and as well as a rhombus and a parallelogram. We are now left with only 2, a square and a rectangle. My diagonals bisect each other, but not at 90 degrees. Definitely the only, a square has got diagonals that bisect each other at 90 degrees, but a rectangle doesn't have diagonals that bisect each other at 90 degrees, which means this one is a rectangle. So I'm expecting you to also be holding or to also be writing in your book right now as we are revising. Right, put each quadrilateral through this classification flowchart. Write down the number where each shape comes out. But we are starting from the beginning, 2 lines of symmetry. right? Which quadrilaterals have got two lines of symmetry? We have a square. A square has got 4, but a rectangle has got 2 lines of symmetry. And then which other diagonal has got 2 lines of symmetry? Sorry, which other shape? A rhombus. Which means this side, yes, we already, I'm going to put these shapes. I'll say shape B is this side, which is a rhombus, which has got 2 lines of symmetry. Yes, it has. So a rhombus is that side. A parallelogram, a parallelogram does not have any lines of symmetry, isn't it? So a parallelogram, a square, let's look at a square. Does it have 2 lines of symmetry? No, a square has got 4 lines of symmetry, which means a square is going to be this side. So I'm going to put A here, isn't it? This side. This is what you're supposed to have done last time. And let's go to the next one. We are looking at which shape? A rectangle. Does it have 2 lines of symmetry, a rectangle? Yes, it has got 2 lines of symmetry, so we put it here. It's this side. So we're going to put a C here. The next shape is a parallelogram. A parallelogram has got no lines of symmetry. So it is this side. So I'm going to put D here, this side. So let me just erase this one because I want them to be in a straight line. It should be A and a parallelogram D. Okay, right. Let's look at the next shape. It is the next shape is a trapezium. A trapezium has got no lines of symmetry, so it should be here. So I'm going to write it here. So it is going to be my shape E here. Right, let's look at an isosceles trapezium. How many lines of symmetry? It has got only 1. So it is supposed to also be here. F. A kite has got 1 line of symmetry, so it is supposed to be here. So it's going to be G. If you look at it, you are going to find out that these shapes are the ones that are over there, isn't it? Right, let's go down again to say on those which are yes. Rotational symmetry of order 2. Which of these shapes B and C, rhombus and C, which is what? C is a rectangle, rhombus and a rectangle. Order 2 is a rhombus. So a rhombus is yes. We're going to put it here, B. It's going to be here. We're now dividing these. Then what of a rectangle, C? Does it have order 2? Yes, it has. A rhombus and C. I'm not sure about this one. That doesn't have 2 lines of symmetry, because for only the shapes that have got 2 lines of symmetry are the rectangle, a rhombus, only those shapes. So I'm not sure why they are here. The other shapes are here, which means diagonals bisect each other. For a rhombus, they do not, but for a rectangular prism, for a rectangle, they bisect each other, which means yes, here it's going to be a rectangle C. So here you're supposed to write a rectangle here. Then this one you're supposed to write a rhombus this side. So these are the characteristics. Then we go on to this side, which has got shapes which don't have 2 lines of symmetry. If we look at this rotational symmetry of order 2, we have got A, which is a square. A square has got order 4. So here we're going to put our A this side. The answer is no. So a square has got order. So we're going to put our square this side. A rotational symmetry of order 2, we have got a square D. So what? D is a parallelogram. Let's look at a parallelogram. Order 2 rotational symmetry, yes. So it's yes. we're going to put our parallelogram this side. It's D. Let's look at the other one, trapezium. A trapezium, we have got two types of trapeziums. Oh, that's the one that is a trapezium. Order 1 rotational symmetry, so it is no. So we're going to put our rotational our trapezium here. This side it is going to be E. F, isosceles trapezium, it has got order 1 rotational symmetry, so it's no. So we're going to put our F this side. G, a kite. A kite, where is it? A kite has got order 1 rotational symmetry, so we're going to put it also here. So we're going to have our G here, this side, isn't it? That's fine. Kelly, I saw your message on, is everything okay?
Yes.
Okay, that's fine. I thought maybe there's something wrong. Maybe you might not be hearing me or whatever. That's okay. Right, the next one. Hello? You were saying something?
I found the video mind-blowing.
Mind-blowing. Can we talk? Can you hear me?
Yes.
You're saying you're not understanding anything, or?
I understand everything.
Oh, that's good. Thank you very much. Then we go on to the next one, which was, we have already arranged them here. Now we are going to, for these ones, diagonals bisect at 90 degrees. A is a square, correct. So I'm going to put a yes here. This is a square. I'm going to put it down here for this. Then for this one, diagonals bisect at 90 degrees. D is a parallelogram. Diagonals don't bisect at 90 degrees. F is an isosceles trapezium. We cannot even talk about it, it doesn't. G is a kite, correct. So here, we're going to put our kite here, isn't it? Then we go on to these ones. Rotational symmetry of order 2, we only have one, which is D, which is what? A parallelogram. Diagonals bisect at 90 degrees. In a parallelogram, it's no. So here, we're supposed to have a parallelogram here. Parallelogram here. So I think I'm done with this one. Let me go on to the next question. Plot these points. If you go to the video that I sent last time, you are going to be able to appreciate the fact that we are able to plot shapes like this on what we call a Cartesian plane. Our book is calling it write down the coordinates of the point where the diagonals cross in each quadrilateral. So what we were supposed to just do was to draw the X and Y axis, as I'm going to be doing here. Let me use probably a green color, right? X and Y axis like this, right? So we're going to name this one the Y axis and this one the X axis. So we were supposed to label this from 1 to like I did yesterday, 1, 2, 3, 4, 5, 6, 7. Then you label this 1, 2, 3, 4, 5, 6, 7. Then you are going to label to find point A, which is 1. We start with the X axis. Point A is 1, 1. It should be here. So this is the point A. We name it A here. Then point B, 1, 2, 1, 2 is somewhere there. Point C, 1, 4, and whatever. Then you were able to know to join these shapes, the shapes that are here. This is what you're supposed to have done, and you draw it on a Cartesian plane. Thank you. So today we are going to just do a simple exercise. We are talking about 3-dimensional shapes, which we all call 3Ds. 3Ds are shapes that have got volume We usually talk of volume when we are talking of the 3D shapes. So the 3D shapes that we have today, probably we will look at very simple shapes like triangular prism, a pyramid. So I want us to go and open our books on page 90. On page 90. If you go and open your, I'm going to be on page 90 right now. Okay, I'm in the wrong page 90. That's what I'm looking for. I usually do this for us to be able to, where am I? Here. This is where I am right now. Okay, this is page 90. A net shows the 2D layout of a 3D object. So I have got this box of mine, it had my earphones here. This box, it had some earphones in there. This is a 3D shape, isn't it? Because it has got a volume, it can carry something inside. Therefore, when we talk of a net, we are saying, let us dismantle this thing such that we have a shape that is how it was before it was made into this. Like this, I'm tearing this, tearing it like this. Then this is now a net and it's now in 2D, isn't it? If I'm going to put these, fold these together, I'm going to get my shape again like this, isn't it? Now I have my shape here. I got my shape again here. Right. So this is a net. To work out the net of a 3D object, imagine a cutting, imagine cutting it along its edges and unfolding like what I have done here. You need to be able to sketch, to make a sketch of the net of a 3D solid. You also need to be able to make an accurate drawing of the net of a 3D solid. In an accurate drawing, all the lengths must be exactly the correct measurements. There are often different ways to draw the net of a 3D solid. For example, here are 3 of the ways you could draw a net of a cube. Here, this is a cube. You can see that it is drawn in different ways, isn't it? These are different ways, this way and this way. If you fold this, you realize that 1, 2, 3, 4 parts. This is 1, 2, 3, 4. They must be in a single line for me to be able to fold it like this, isn't it? Right. So you can draw the sketch of the net of a square-based pyramid like the one that we have here. That's the sketch of a square-based pyramid. This one is a net of a rectangular prism, a triangular prism, sorry. So today's work is more of these nets. So we're going to do number 1 up, on page, let me just look for the textbook. We are going to open our books on page 50 something. Right, I have it with me here. On page 46. On page 46, then we are going to sketch a net for each cuboid. Which of these could be the net of a cuboid? Number 3, number 4, number 5, 6. I think up to number 6 only, and we end there. So it is a very easy piece of work that we have today. Thank you very much. I hope you have learned something. If you have got something to say, please, would you like to just send me a message and ask for any assistance? Thank you very much.